Hey everyone! It's an unfortunate fact of life that many of us have at some point broken a bone or two. Even if you've been lucky enough to never break a bone in your life, you probably know someone who has. Luckily for us, our bones are not just lifeless scaffolding that our bodies use for support. Bones are dynamic structures, and so are generally very good at responding to damage and rebuilding themselves. This means that if we do have a clumsy moment, we don't end up with one of these for the rest of our lives. In this tutorial, we're going to look at the microscopic structure of bone tissue, learning about its unique and highly specialized morphology and how this facilitates healing of skeletal structures. Bone tissue is a specialized connective tissue that forms the adult skeleton. As well as providing structural support for the body and its tissues, it also protects vital organs and provides surfaces for muscles to attach to. This, of course, is especially important for movement. Bone is very metabolically active. It stores calcium and phosphate ions that are needed for other tissues in the body, like neurons and muscles. It is also the site of hematopoiesis, which involves the formation of blood cells. There are a few different types of bones found in the body. These include long bones, flat bones, short bones, sesamoid bones, and irregular bones. Long bones, like the femur here, are mostly found in the limbs. These are the types of bones your dog likes to chew, or those that you might see if you somehow manage to find yourself on a pirate ship. Long bones have three regions with distinct structures, a diaphysis in the middle, and two epiphyses at either end. Flat bones, such as the parietal bone of the skull, are broad and relatively thin bones. Flat bones often sit with other flat bones and form defined spaces or cavities, such as the cranial vault. Short bones are those knobbly little round bones found in your wrist and ankle joints, like the lunate bone here. They tend to have strange names based on their perceived shape. For example, lunate here means moon-shaped. Sesamoid bones, like your kneecap or patella, are rounded bones which form within tendons. These bones work to increase the mechanical advantage of the muscles whose tendons they're found within. And finally, irregular bones are those odd-shaped bones that do not resemble any particular shape and just don't fit into any of the other groups mentioned previously. The bones of the spinal column, like this vertebra here, are examples of irregular bones. Now let's put these bones under a microscope and see what's really going on in there. We're going to go over the types of tissue that make up bones, how their matrix is organized, and the cells found within them. There are two main classifications of bone tissue. These are woven bone and lamellar bone. Woven bone is a relatively weak type of bone tissue which is still developing, and its matrix is unorganized. This is the type of tissue bone seen in fetal bones like the one here, or in bones which have been recently fractured. Lamellar bones, on the other hand, is the mature type of bone tissue which you find in all developed bones. It is formed from woven bone, which has been remodeled to increase its mechanical strength. Let's take a closer look at lamellar bone. There are two types of lamellar bone, and these are compact bone and spongy bone, which are largely differentiated by how these groups of concentric layers are arranged or organized. The first type of lamellar bone is known as compact bone and is also called cortical bone. Compact bone is the type of lamellar bone tissue found in the hard outer region of a bone. It is highly calcified and very strong, but of course will still fracture with enough force. Compact bone tissue is characterized by its densely packed functional units known as osteons, which consist of a series of matrix layers surrounding a central canal. We'll explore osteons in more detail in just a moment, but first let's talk a little bit about the second type of lamellar bone, which is spongy bone, also called cancellous bone or trabecular bone. This is the lamellar bone tissue that forms a supporting framework for the medullary cavity and the ends of the long bones. Spongy bone is more delicate and breaks easily. It is generally surrounded by bone marrow and forms a spider web of bone trabeculae within the cavity. These trabeculae are formed from thin bars of lamellar bone. Occasionally, when these trabeculae are particularly thick, they may also contain osteons. Now that we've gone over the various types of bone tissue, let's look even closer. Firstly, at the components of the extracellular matrix surrounding the bone cells. This over here is osteoid, which is the soft organic component of bone extracellular matrix. Osteoid is most easily seen in developing and growing bones because the matrix has not yet been mineralized. Mineralization is the process by which calcium and phosphate ions are deposited into the osteoid and make bone tissue strong. When calcium and phosphate ions bind to each other, they form something known as hydroxyapatite crystals. The crystals are deposited onto collagen molecules within the osteoid and the bone tissue becomes rigid. Our micrograph here has been prepared with an H&E stain. With this type of staining, the osteoid appears much lighter in color and less organized than the matrix of the mature bone around it. Let's look at mineralized bone matrix. Moving over on our slide here, we can see the spongy bone tissue within the medullary cavity, referred to as the bone matrix. These are blood cells and fat cells within the marrow. The small purple cells here are osteocytes, mature bone cells, which we'll introduce to you shortly. and the smooth pink area around them is the mineralized extracellular matrix, or bone matrix, highlighted in green. Now that we know the basics about bone matrix, let's explore the organization and relationships of structures within the bone tissue. Bones are covered by a protective structure called the periosteum. The periosteum is a double layer of connective tissue. It has a fibrous layer and a cellular layer, also known as the osteogenic layer, that surrounds the bone and transmits periosteal nerves, arteries, and lymphatics. Beneath the periosteum, the matrix of mature bone tissue is organized into a system of lamellae, or layers, highlighted here. Osteocytes are found between layers of bone matrix. The layers are often organized into groups called concentric lamellae. Concentric simply refers to when one layer completely surrounds another, like we can see in green here. All of the layers of matrix in one group of concentric lamellae are collectively called an osteon. In compact bone, the osteons are aligned in parallel and provide strength to bone tissue. They are highly organized units of bone tissue with several defining features. For example, there's an open space in the center of each osteon.
This space is called the central canal of the osteon, also sometimes called the Haversian canal. The central canal contains blood vessels that bring nutrients and oxygen to the bone tissue. The blood vessels that travel through the central canal have small branches that course through layers of concentric lamellae to reach more peripheral regions of bone tissue. These are called perforating canals of Volkmann. Unlike the central canals, the perforating canals of Volkmann appear more oval or elongated in cross-section.
The network of arteries traveling through osteons are important in healing as they bring white blood cells to clean up broken bone tissue so new matrix can be deposited. Along with canals transmitting blood vessels and nerves, there are small spaces in the matrix of osteons. These spaces are called lacunae. They're found here, in between layers of lamellae, and contain bone cells known as osteocytes, which are completely surrounded by matrix. Although they're encased in bone matrix, these osteocytes retain connections with each other through small cytoplasmic extensions that pass through canaliculi. Canaliculi are small tunnels within the bone matrix that sometimes can resemble spokes of a bicycle wheel, radiating from the lacunae. Along with the concentric lamellae forming osteons, bone tissue also features interstitial lamellae. These are intervening layers of bone matrix that do not completely surround any central canal, like the ones highlighted here. Finally, circumferential lamellae line the surfaces of bone tissue. Outer circumferential lamellae are found deep to the periosteum, and inner circumferential lamellae overlie the endosteum. Now that we've gone over the major features you'll find in mature bone tissue, let's now look at the inner region of bone. The inner region of long bones is usually called the medullary cavity. There are some exceptions. For example, the inner region of the flat bones of the skull is called the diploe. In adults, the medullary cavity is the part of the bone that generally contains yellow bone marrow. This is the bone tissue, and this is the bone marrow. Marrow is primarily made up of blood cells and adipose tissue. The marrow of the medullary cavity is surrounded by a delicate network of spongy bone called trabeculae. This network forms a lattice-like frame to support the developing blood cells and adipose tissue of the blood marrow. This is another slide of the medullary cavity. Similar to the outer surface of the bone that was covered in periosteum, the trabeculae of the medullary cavity are covered by a connective tissue layer called endosteum, which you can see now highlighted in green. Alright, now that we've seen the matrix supporting bone tissue, let's describe the cells found there. Bone cells begin as osteoprogenitor cells, which are mesenchymal stem cells that subsequently divide and differentiate into immature cells, known as osteoblasts. Let's look at some here. This is a Mallory trichome stain, which is particularly suitable for viewing these types of cells. We've highlighted some in green here. They're located on the free surface of bone matrix. Osteoblasts secrete the components of matrix. As they do, they surround themselves completely with bone matrix. When the osteoblasts mature and are embedded in their secreted matrix, they are then referred to as osteocytes. Osteocytes are the differentiated cells of bone tissue. They reside within lacunae, small hollow spaces in the bone matrix. Although each of the osteocytes reside in their own lacuna, they maintain communication with each other through small cytoplasmic extensions, which we learned run through the canaliculi of the bone matrix. There's another type of very important bone cell, the osteoclast. Osteoclasts are special cells found adjacent to osteoblasts. They're large cells that function to break down bone tissue. Why, I can hear you asking, do we need cells to break down our bones? Surely that makes no sense. Well, actually, it does make sense. In fact, it's completely necessary for a cool process known as remodeling. In remodeling, existing bone tissue is broken down and new bone tissue is built in its place to alter or maintain the shape of the bone. Remodeling happens continuously throughout life in response to changes in diet, weight, and activity level, and also in response to stress and injuries such as fractures. Osteoclasts are important in this process because, like most building processes, we've got to get rid of the old before bringing in the new, and our osteoclasts do just this. When directed by osteocytes, they break down the old or damaged bone matrix by means of enzyme and acidic secretions, which eventually is returned back to the blood. This is known as resorption of bone. When they've broken down the required amount of bone, osteoclasts undergo apoptosis, which basically means they self-destruct. From here, the friendly osteoblasts arrive and start rebuilding the new bone in place of where the old bone was. One interesting note is that exercising, especially when it involves carrying around extra weight, stimulates bone remodeling, which leads to greater bone strength. So for those of you who enjoy working out, did you realize you're building bone as well as muscle? Now that we've looked at the cells and organization of bone tissue, let's look at what happens when it breaks down too quickly. Osteoporosis is a disorder characterized by reduced bone mass. It is often associated with aging, but can occur at any age. There are two main types of osteoporosis: primary osteoporosis that follows menopause, and secondary osteoporosis that is a result of another disorder or medication. As we saw earlier, osteoclasts are the cells that break down bone tissue. In osteoporosis, the osteoclasts function with increased activity, while the osteoblasts, which rebuild bone tissue, tend to demonstrate reduced activity. The result is a net loss of bone mass and increasingly brittle bones that fracture easily. On the right side here is a representation of trabeculae in healthy bone, and on the right we can see a representation of osteoporotic bone. The differences in structure here should give you a pretty good idea as to why osteoporosis can affect the structural stability of bone so much. And with that, we've reached the end of this tutorial. Let me quickly recap what we've learned today. In this tutorial, we looked at the major features of bone tissue. We looked at the bone matrix, osteoid, and the cells of bone tissue, osteoblasts, which are the immature cells that secrete bone matrix, osteocytes, which are the mature cells that reside in lacunae, and osteoclasts, which break down bone tissue. We also looked at how bone tissue is organized into a series of layers. First, it is surrounded both internally and externally by layers of connective tissue. Periosteum surrounds the outer surface of the bone, and endosteum lines the inner surface of bone adjacent to the medullary cavity. The medullary cavity is the center of a bone and is filled with adipose tissue and white blood cells and is supported by a network of spongy bone trabeculae. We also examined osteons and their major features: Haversian canals, Volkmann's canals, lacunae, canaliculi, and additionally, we looked at the main types of lamellar bone tissue, which include compact bone and spongy bone. And now we've reached the end of our tutorial. Thanks for watching.